Okay, so this is Geometry Unit 4 Triangle Congruence Test Review Part 2. So we're going to use the diagram for each one of these things. So what I'm going to do is I am just going to copy this diagram 2 more times just so I can write on it and you guys can see it without erasing. Okay, so the first thing says if Wx and is congruent to Wz, what postulate or theorem can be used to show that triangle PXW and triangle PZW are congruent? So the first thing I'm going to do is I'm just going to say, okay, we're going to just kind of PXW, so this triangle, and then PZW is that bottom triangle. All right, we already know here it says that we're given that these two pieces are congruent. And then we are told that WX is congruent to WZ. Now, we know that PW is congruent to itself by reflexive. So PW is congruent to PW by the reflexive property. So that means we have side, side, side. Now let's look at the next one. If XZ is perpendicular to YW, which theorem can be used to show that XYP is congruent to triangle ZYP? So XYP, we're looking at this one, and the other triangle is directly below it. All right, so we know that if it's perpendicular, that means that each one of these is a right angle, okay, right? So I can say this is a right angle here, and this is a right angle. It's kind of hard to see. Let me see if I can redo that a little bit. Oh, got rid of a lot of things. So we have, and then we have this one. All right. So I know that this is a right angle, and this is a right angle. And then I also know that PY is congruent to PY, again, because of the reflexive property. So there I have side, angle, side. Now the next one says, if XW is parallel to YZ and angle XYZ is congruent to angle ZYX, what postulate or theorem can be used to show that triangle XYZ, so XYZ, it's this big triangle here, and triangle ZYX. So we're looking for those two triangles. Now we are told that they're parallel, so let's just do green. This is parallel to this, okay? And then we are also told that this angle is congruent to this angle. Now, based on parallel lines, the transversal parallel lines, I can say that this angle and this angle are congruent for alternate interior angles, okay? So for that, I have, and of course, XZ is congruent to XZ, again, based on reflexive property. So I have, this is congruent, I have angle, angle, side, angle, angle, side. So it's angle, angle, side. Okay, so now for number 10, I went ahead and copied that diagram over, and it says if angle BAC is congruent to angle DCA, what postulate theorem can be used to show that triangle ABE is congruent to triangle CDE? So I'm going to go here triangle ABE, so ABE right here, is congruent to triangle CDE right here. All right, and we are told that angle BAC is congruent to DCA. So right now I have a side and angle. Now I know that these two angles are congruent by vertical angles. So I can say that this is angle, angle, side. Angle, angle, side. Now looking at the next one, if segment BD bisects segment AC, what postular theorem can be used to show that triangle ABE is congruent to triangle CDE? So I'm going to first ABE. ABE, it's the same two triangles. CDE. Okay, and then it says it bisects. So if it bisects, I know that this and this are congruent, and I know that these two segments are congruent. So then I have side, side, side. All right, and then the next one says if AB is parallel to CD, what postular theorem can be used to show that triangle ACD is congruent to triangle CAB? So ACD would be ACD, and then CAB would be CAB here. All right, and then it's saying that they're parallel. AB is parallel to CD. All right, so we know already that AC is congruent to AC based on reflexive. So I know that this right here is going to be congruent to itself. If these two are parallel, that means I can also do the alternate interior angles, which means that they are congruent. So that would be side, angle, side. So side, angle, side. Make sure you bring any questions you have.